Yeah, thanks, John. We built this thing here, and if you wear it on your arm, your skin is starting to itch just drastically. So I'm going to later on talk about how we do this and all that. But at this point, the big question on your mind is probably not that. The big question is probably why would you want that? Because why you want your skin to itch? I mean, normally it's not something we want. And we came to this from a specific angle, and it's kind of the corner of natural user interfaces, right? And if we look at, for example, here, there's one of the things that NUIs are or should be from Wigden and Wixter, and they say create an experience that for expert users can feel like an extension of their body. And we thought that's super nice. But somehow there seemed to be a bit of an issue in our field how we use that definition. In that in natural user interfaces, somehow we only really talk about input. And the book is called Touch and Gesture, and that kind of already alludes to that to some extent. And we were wondering, well, can we do some kind of natural user interface output as well? Because the user interface cannot just be input. And so we looked at what kind of natural ways to output are there. And here are a few examples. So maybe you're cold and you're shivering, or you're yawning if you're a very tired baby. Maybe you have some stomach problems, or your stomach hurts, or you're sweating. And all of those things are something happens there where your body maybe tells you not to do something, or to change your behavior some way, or to do something. Like yawning, you probably should go to sleep. If something hurts, you probably should not continue doing what you just did. So there's those, but in fact there's a huge range of those, and we put some list here, and they not necessarily have one exact thing that they mean. So if you're sweating, it could be because you went on a run, but maybe you just have to go on stage and you have huge anxiety, and that could also induce sweating. So it can have many different meanings, any of those. But there's a huge range of things that potentially we could be using to provide feedback as our body does. But we only picked one, which is itching. And I put a few things here that are connected to itching. We're not doing bugs. We're doing it out of a few other reasons. So we looked in the literature, and in fact there's a whole bunch of things on itching. So there's a really nice book from Eccleston, Embodied the Psychology of Physical Sensation. And there's many more things about itching, but there's 3 things about itching that make itching just really interesting for interactive systems. One, it captures our attention really well. So Eccleston writes, itch, like pain, functions primarily to interrupt. So interruption is built into the sensation. But not just interrupting us, itching also prompts us to act. He writes, itch functions to urge scratch. Itch cannot exist without the urge to scratch. And that's not the only one where that happens. You could think about the sensation of being hungry. You cannot be hungry without wishing to eat. Like the act of eating is inherently tied to the sensation of feeling hungry. At least I could not imagine being hungry without wanting to eat. And finally, and that one is slightly weaker, but I think it's kind of interesting in this respect, there's something like a unique built-in reward structure about itching, in that it can actually be kind of pleasurable to stretch yourself. Not always. If it's some kind of more medical long-term condition, the pleasure kind of goes away. But we can see it in language even, where the notion of scratching an urge, that has kind of found its way in there. But if you do something that then finds some pleasure to you, that can be kind of nice. And even not just the act of scratching, just getting an itch to stop has an inherent kind of pleasurability about it. Okay, so this sounds really nice, but can we actually get people to itch? Well, there's a whole bunch of ways you can do that. So first of all, there's the biochemical route. So if I push you into a field of poison ivy, you'll probably start itching intensely. For interactive systems, though, that might not be the ideal route to go. It's easy to get you to start itching, but it's kind of hard to get you to stop itching. Also, those kinds of biochemical approaches don't really mesh that well with the wearables that we have today. I'm not quite sure how to get that into a smartwatch or into a phone, so maybe not ideal. There are some weird ways you can do it by mechanical stimulation. So Fukuoka et al. Had this project where they had a tiny wire swinging above your skin, just lightly touching your hairs, and at some point you start to itch intensely. But you might imagine, once you move around, that can be kind of tricky to put into a system. Another way you can do it, which is kind of interesting, is you can just show people pictures of other people scratching themselves. And sometimes, not always, that gets you to itch, or at least it gets you to itch more. And you can do other things. You can show people pictures of skin conditions, of like insects crawling on your skin, and that also works. I'm not sure we want an interactive system where you then have to look at those images half the time to then get some feedback. So probably also not the best choice. So we went with electrical. And the nice thing about electrical is it's known to work. Right, so there is really old, but there's kind of lots of research around electrical stimulation to then induce itching, primarily from the medical field. So Bishop, for example, did a study in 1943 where he already showed us, yes, with electrical stimulation you can get to itching. And there's been comparative studies that show with electrical stimulation you can get the same amount of itching as with histamine administration. So great. But apart from knowing that it works, there's also it's just kind of easy to put that into the variables we're already using. We can integrate it. We can control it with the microcontrollers, with the CPUs we already have in place. We can switch it on really fast. We can switch it off immediately. And it's just kind of easy to build. And to illustrate in this some way, I want to show you some examples of like this larger space of using electricity to give you some kind of sensation. You can go to the store right now and you can buy any of those devices, and then you can go home and you can get an app workout, or you can do a cranial stimulation, all kinds of things. Essentially, they're all using the same principle of putting some current through your body, and then something happens. Sometimes the muscles do something, sometimes the nerve trigger, all kinds of that. And this is all really nice, but we did want a bit more control over what's happening there. We didn't just want to do setting 5 on stimulator X. And also we wanted to see, can we make this into something that is more of a wearable form factor thing? So we built this thing here, which is a really simple electrical stimulator. And it just snaps on one of those Adafruit boards, so it's kind of like an Arduino. And then it has a boost converter stage. And then we have a current regulating stage, so we do constant current stimulation, and then we have an H-bridge output stage. This is not fancy, honestly. I mean, if you go to the literature, and you can find it from our paper, you'll find there's tons of designs that basically use this in some form or the other. And this allows us to finally adjust pulse width, frequency, and amplitude, and it's small, it's mobile, and it's open source. I'll show that at the end. All right, so now we have this system and we want to kind of get people itching. So we did a few evaluations. In fact, we did 2. One is, we know there's itching, but it's still this kind of complex, large space. I wanted to find out, well, how can we actually get to itching? But we don't want, we want something to happen, and definitely not muscle activation. How can we get to itching? But we also wanted to compare it against something that is already in wearables. So we choose to do something where we compare itching against vibration. All right. But let's start with the first one. I want to find out how we get to itching. And the problem is that the parameter space for those electrotactile stimulators is huge. And even if we go with previous work, they don't all report the same numbers of settings, what you should do to get itching, so the range is kind of vast. I mean, we did previous work where you can use interactive exploration to kind of cope with that, but here we didn't really want to tell people that we want to get them to itch, because if you tell them that they're going to itch, they're probably going to itch. So we had to hide that from them, so we couldn't have them search for it. So we kind of had to go for random exploration, so just random sampling and then seeing what happens. So this is what we did. We did like a really basic 2 electrodes on the arm. We gave them random stimuli, and then we asked them, what does it feel like? But before we start with that, we of course have to do some calibration. If you put too much current in the arm, then this happens, right? Then your hand starts to actuate, as like here in possessed hand. And that's not what we wanted. We wanted only electrotactile sensations. So we had like a very initial phase where we just randomly choose stuff, and then we fit a plane through the parameter space, and we say, okay, everything on that side where there's muscle activation we don't want. And we then just constrain ourselves to the other side. Okay, so we run that, and people had a whole bunch of sensations. So you can see here, majority of those, gentle, vibrating, localized, faint, diffuse, prickling things. So not really itching. Which tells you the space is so vast that all kinds of other sensations are in that space, right? And so little itching? Wait, that's a bit concerning. But no, this is just a result of us doing random search in a vast space. In a second phase of that first study, we did constrain ourselves a little bit more. We reused those 24 instances, and we did a few more random sampling, and then we actually told them, please rate itching, and then we can do something like that, where we get an itching rating from people, and we see actually there's a whole bunch of stimuli that are at least medium itching. And here we do a little Gaussian process regression to find out, well, is there some relationship between itching and comfort? And it's noisy, but overall it looks like more itching makes you less comfortable, as might not be very surprising. All right, so after this we have kind of an idea where itching happens, right? We have those few crosses here on the right where itching happened, so we can use that to average them together, and then now we know with our setup, with this kind of stimulator, something like a 60 Hertz frequency signal, 3.8 milliseconds pulse width, and 0.2 milliampere amplitude probably induces itching in what we have. But, of course, if you have a different setup, you'll probably have different numbers. So this is something that does require calibration. And again, if you think back to all those terms people picked, there's just a whole bunch of other stuff in there, and you need to spend some time getting people to actually itching. All right, but now that we have that, let's actually compare itching. So against something that's vibration, not itching. So here we have our smartwatch prototype again. And first of all, the question is, well, if we actually use stimuli where we think it's itching, does that actually work? And yes. So here we only use those pre-configured. We do a little bit more calibration so people could like ramp up the intensity slightly if they didn't feel too much. But here we had like 90% of trials there actually was itching. So you still have cases where a participant kind of at some point maybe doesn't feel some itching. And for some people the watch was not quite fitting super well, and then there can be some problems. But overall, once you've calibrated a little bit, you can get pretty decent itching most of the time. I want to quickly do a little bit of a side thing here and mention why do we want to go for smartwatches. And I think it's a very interesting platform in that you can just nicely put electrodes on it, and then they're directly on people's skin. And it's a platform where we also have a huge interest in doing something that has low energy requirements. And as you saw, we have a 0.2 milliampere signal that's also off most of the time. So the total power requirement is minimal. There's no moving parts. So compared to vibration, this offers quite some benefits. And I'm talking about itching here, but as we saw just a few slides ago, this also holds true for all kinds of other sensation, like weird, gentle, prickling, vibration stuff. There's a huge space. And we did it on the watch here, but in fact you can put it on other parts of the body. So we saw earlier here at UIST, with Tech 2, you can kind of put some stickers somewhere on your skin, like a tiny little sliver, and then that also allows you to do electrotactile actuation. You can also do like thicker, like silicone sleeves, like there's some work by Ying et al., and they kind of put it on the finger, but you could put like a silicone thing somewhere else. And there's also previous work by Lee and Starner where they looked at integrating electrotactile electrodes into like a textile substrate, and that also seems to work. So while we look at the wrist and smartwatches, I feel this could be something for many other devices and locations on the body. But all right, let's look at the results of our second study. And here we really asked them to compare itching and vibration. And what do we find? Well, for one, itching is much more activating and interrupting. So if you feel, not just do you immediately notice it and you kind of feel thrown out of whatever you were doing before, you also really feel that you need to do something about it. That's the activating part. So that's a big difference. But you might not always want that, right? So if we ask people, okay, so this is activating, interrupting, but where is it actually preferable? We find, well, overall, people really like vibration because, as it turns out, people do not want to be activated and interrupted that much all the time, surprisingly. But depending on the scenario, the kind of openness to being massively interrupted and activated changes quite a bit. So, for example, we can look here. You have like two examples. We asked them, well, your fitness app informs you that you achieved your daily goals or that you should exercise more. If you achieve your daily goals, that's a nice thing. Then they definitely don't want to be itching about it. But if you want an app to like really get you to do something about something that's kind of unpleasant in the first place, starting to itch a little bit about it apparently is more acceptable. But still, if you look at the overall distribution, overall people don't want itching all the time, right? So it's something that is kind of reserved for maybe more serious, somber or negative, or some work event that's really important, but not something where you just constantly itch. All right. We also asked them all kinds of qualitative questions, and we interviewed them afterwards, and there were a few things that really stood out. One, they confirmed this strong need to act that previous workers already hinted at. So they told us things like, you feel that urge to scratch, right? I mean, you kind of want to do something about it. One even says you're forced to react, which is much stronger than you would have with other sensations. Tied to that, it is just generally more intense, hard to ignore, urgent, much stronger are things that people said in relation to this kind of sensation. And on the other hand, if you look at what they say about vibration, well, it's something comfortable, good, positive, more relaxed. I should note, though, to some extent, we use the standard vibration messages in the Apple Watch, so obviously Apple has not much interest in making it really uncomfortable. So that's a bit of a constraint of that. But vibration feedback, as it is used in devices today, has those properties. And there's one final one that I thought was really interesting, and that kind of harks back to this aspect of naturalness in some way, and that is that people told us that itching somehow was an internal sensation, or they perceived it as an internal sensation, but vibration was not. So for itching, people told us something like the origin was inside their arm. So somehow the actuator wasn't, right? The electrodes, the watch, sat outside their arm, but they perceived it as something that happens inside their arm. And on the other hand, they tell us vibration acted from the outside. So there is vibration, and I perceive it in my skin, but it's coming from somewhere else. So there's some weird thing happening, and it might be just our history of our own experiences, our bodies, that gets us to believe if it itches, it's probably something from within. But vibration is not something our bodies usually do, so it must be something external and unnatural. So if we summarize this, itching is great, it's interrupting and activating, but it's also kind of uncomfortable. So you got to balance it to some extent, right? I mean, if you can't have something that's always interrupting and uncomfortable, but maybe sometimes that's fine. You can do it electrically, and that allows you to do it in a small, mobile, and low-energy form factor, so potentially in a smartwatch. It's an internal sensation. There's something interesting about it, but that definitely requires some future work to figure out what that actually means for the notion of naturalness. And finally, we looked at itching here, but as we saw in our first study, there's a whole bunch more to explore, and potentially you can have like a smartwatch that not just only makes you itch, maybe it just also creates gentle vibrating sensations to soothe you down. All right, that's it for me. If you want to grab the board, the schematics and files and the code, I must admit it's research code, but you can grab all that at GitHub. And it's linked in the paper, so you don't need to copy it from here. And I'd be happy to answer any further questions you might have.
Okay, great questions.
Rong Hao Liang from TU Eindhoven. Thanks for a great role. It's very inspiring, actually. I think that you already introduced a good, strong notification for people to know something that is happening. But I was wondering about the way to respond to that issue. You know that the first thing that we will react to the itching is to scratch, but scratch does not stop the notification. Yeah, So
we at some point made the decision not to implement scratch input because that's kind of been done. So there are systems out there. I mean, Chris Harrison's work, for example, right, where you can it doesn't even need to be at the site. It can be like some strap somewhere else that picks up on vibration that happen when you scratch. So there are systems out there that can recognize scratching. So you could combine those kind of input devices with our output device to give you the whole interactive experience and make it stop.
Okay, thanks.
Hi, Santiago from Intel. Really interesting research, and it makes me have a lot of questions, but I'll start with one. Did you ever, during your study, did you encounter anything like phantom itching, which is something that would happen like when you don't have your cell phone in your phone on your pocket, but you think it's vibrating? Itching would be so much more inside your body that I'm guessing phantom itching would be a problem.
Okay, so I mean, I made myself itch a lot. I can admit to that. I would say so. There is this effect that if you had it on your arm for quite a while, and you just, I mean, there is like a certain numbness, but also it kind of lingers. So I would say that's there. But I never had the experience of like the next morning waking up and itching, because like yesterday evening I tried out the system. So I mean, I can't say it never happens. Because who knows? Maybe somebody experiences it, but I personally never experienced that kind of sensation. No.
Thanks.
Gregory Abau, Georgia Tech. First of all, I want to thank you for forcing me to itch throughout your entire talk. I had a comment and a question. For the question first, do you control when the itching stops? So if you stop the electrical stimulation, does the itching sensation stop?
It generally, yes. But
can you define generally?
So again, from my own experience, like if you have it running for quite a while, at some point your skin gets a bit numb, right? Because I mean, if you basically run like an AC signal for like an hour or two through your skin, it does something. So there shouldn't be charge buildup. So it is a system that is, because it's biphasic, it charges, but it also discharges the skin. So there's no DC current buildup in the skin. But still, I mean, you constantly kind of trigger the nerves. That does something. I found like on shorter time periods, like the people in our studies that were like 20-minute, max half an hour studies, in that time frame I did not experience that. I think it's basically you turn it off and the sensation turns off. However, once people have, I mean, it raises skin awareness, right? So once you kind of put the focus of people on their skin, they tend to kind of be more aware of other things maybe happening. So I can, from my personal experience, say this. So like once you kind of have been itching and scratching for quite a while, it just kind of lingers in the back of your mind. So I would say there's a bit of sensitization. But as you turn it off, it definitely isn't the same intense sensation as before.
So then, just a comment, I was thinking as you were presenting this, you know, what would be the value of something like this? What always gets me, I'm not wearing my smartwatch now, but when I get an alert, a vibration, and I'm in a social situation, it's still awkward to have to look, right? But if you're scratching, you bring the screen towards you, so it's actually kind of socially appealing to scratch and then check the messages on there. That's really nice.
Yeah. I mean, we did go for this property, right? Like, in a way, if you show your notification on your smartwatch, you kind of want people to move their hand to the smartwatch, and like getting people to scratch kind of naturally moves their hand to the smartwatch, as awful as that might be, but yeah.
Great. Well, let's thank Henning for a head scratch.